Okay, so this video is just to support the second half of Objective 3, so graphing, some more polar graphing here. So if we, so we're just going to go through and do, I think there's like 10 problems here. So we're going to graph r equals 4 cosine theta, and so for this one right here, so we're going to start out with using the table. So I'm going to use the tables on some of these, and some of them I'm going to do without the tables just to kind of remind you how to do that. So if I take a look at theta equals 0, so I'm going to do 4 cosine of 0. And I know that the cosine of 0 is 1, so 4 times 1 would be 4. So for my polar graphing, sorry, I usually just draw an xy, and I don't draw in the concentric circles. So at theta equals 0, I'm going to go out 4 units to the right, or towards the 0. And so if I just do that, 1, 2, 3, 4, so that would be right here. Okay. And then if I take a look at pi over 2, so this would be 4 cosine of pi over 2. And I know at pi over 2 cosine is 0, so 4 times 0 would be 0. So at pi over 2, which is right here, my r value is 0, so I would go nowhere. I would be at the pole. So right there, that's at my pi over 2. And then let's do pi. So I would have 4 cosine of pi. And I know cosine of pi is -1, so that would be 4 times -1 is -4. So this is pi. So normally I would go towards pi, right, if r were positive, but because it's negative, I actually have to go to the right. So for pi, I'm going to go right 4 units, so 1, 2, 3, 4, and it's just that same dot. Okay. And then I would have 4 times cosine of 3 pi over 2. And so the cosine of 3 pi over 2 is 0, and 0 times 4 is 0. So I only have 2 dots here. If this were not enough, like I couldn't figure out, well, what the heck is that graph? Then I would actually plot a few more points. Like I would maybe try, pi over 4, pi over 3, pi over 6, that sort of thing, just to kind of get a few more collection of points so I have something more to graph. But we are working on equations with recognition of the graph, right? So if I look at this, I have no adding or subtracting, so I know kind of it's in that petal family. So if I look at this b is 1, so, and because it's odd, I would have 1 petal. But it's not a teardrop, right? It's not a teardrop petal. It actually then, a single petal is your circle. So then I would just create a circle with that radius of, diameter of 4. Okay. And so that is how I would graph it. And then for the start and the stop, I know at theta equals 0, that's always where my start and stop are. My radius is 4, so then my start would be actually right here, right? And then I would head in a positive direction towards pi over 2, which would be counterclockwise. So it would look something like that. Okay. And then if I were to just kind of graph it given the equation, I know that I have a positive value here and cosine, and I know that cosine is positive to the right, which also gives me the idea that I should be in these 2 quadrants here as well. Okay. All right, so you should pause and try number 2 on your own first, and then just play it and skip forward and see, do you have the right answer or not? Okay, so let's talk about how would I graph this. So I should always evaluate at least at theta equals 0, right? Because that's my start and my stop point. So I want to go ahead and do at least that part of it. Oops, how about at 0, not theta? So I know sine of 0 is 0, so 0 times 6 is 0. So let me get a graph here. And so that will be my start there, right, at 0, 0. So I know, so when I look at this, I can do, oh, this is a positive sine graph, and I know sine is positive above, and it's not a limosone, it's not a cardioid, and that's because there's no adding or subtracting, so it has to be in that kind of petal family. And then b is 1, so an odd, so that means there would be 1 petal, right, kind of 1 petal, So, but we don't draw like that diamond shape, right? Or that teardrop shape. We know it would be a circle, one petal circle. And it has a diameter of 6, meaning I'm going to go out 6, and I'm going to do that going upward. So 1, 2, 3, 4, 5, 6. And then I do the best that I can. Won't ever be perfect to draw a circle that is pretty uniform. Okay. All right, and then again, I could fill in the table if I wasn't sure. All right, so let's take a look at question number 3. So if I have r equals -2 cosine theta. So again, you can press pause and try to do this problem first before I do it for you. So if you're confused by, well, there's a negative there, what do I do? So again, if you don't know, you should always do the table. So if you're like, oh, I don't know. So let's go ahead and replace theta with 0, just to kind of see, well, what does happen if that was negative? So I know that the cosine of 0 is 1, so 1 times -2 is -2. So here's 0, but because r is negative, I'm not going to go towards 0, I'm going to go away from it. So I would go 2 units to the left. And then if I evaluate at pi over 2, cosine of pi over 2 is 0, so that would just be 0. So here's pi over 2, so at 0. And then for pi, whoops, goodness gracious. So at pi, so -2 cosine of pi. And I know cosine of pi is -1. So that would be +2. So if I was over here at pi, I'm going to go 2 units towards pi, and that dot's already there. And then so on, right? So again, the other way is if I know, oh, hey, this is not a cardioid or a limacone of any sorts because there's no adding or subtracting here, so it has to be in that petal family. And B is 1, which is odd. So it'd be 1 petal, but not like that teardrop petal. So 1 petal graphs are really circles. And I know that I have a negative cosine, so that would be here. So that means my circle is going to be headed this way. And then I plotted a couple points that kind of give me that kind of indicator. And so then as best as I can, I'm going to draw that circle. And then my start was at 0, -2, so that's this guy right here. And then always in a positive rotation, which is counterclockwise. Okay? All right, so let's take a look at a few more here. Okay, so for question number 4, so I have 4 plus 2 cosine theta, 4 plus 2 cosine theta. So I know this has got to be some sort of cardioid, limacone, kidney kind of graph. So if I take a look at these numbers here, so my A is 4 and my B is 2. So 4 is bigger than 2, so then that means it's going to be a kidney, right? So if it was the other way, so less than has the loop. Less than, less than loop, limacone. Okay, so it's not less than, not a loop. Technically is a limacone, but not a looped limacone. Okay. So if I wasn't sure, like, how do I graph it, I should always plot points, get my points plotted, and then hopefully I create enough points to, like, kind of lead me into that, oh, right, that's what it's supposed to look like. Okay, so let's go ahead and plot a few points here. So I'm going to replace theta with 0, so that would be 4 plus 2 cosine of 0. And I know the cosine of 0 is 1, so that would be 4 plus 2 times 1, or 6. And then I know that's my start point there too. Okay, so then I'm going to go to pi over 2. So I'm going to replace theta with pi over 2. So I know cosine is 0 at pi over 2, so that would just be 4 plus 0, or 4. So then I'm going to go up to pi over 2, and then out 4 units. And then I'm going to do the same thing at pi. So I'm going to replace theta with pi, so that would be 2 cosine of pi. And then I know that cosine is -1 at pi, so that would be 4 minus 2, which is 2, and here's pi. So because it is 2, so I'm going to go towards pi 2 units, so that would be right here. And then one more, because I don't really need to do 2 pi, right? Because that's the same as graphing the 0. So I'm going to replace theta here with 3 pi over 2. And then I know that 3 pi over 2, or at 3 pi over 2, cosine is 0, so that would be 4 plus 0, which is 4. So 3 pi over 2 is down here, so I'm going to go 4 units towards it. So I have these 4 dots, right? So with those 4 dots, what I need to think about is that I have kind of like, okay, how do I connect to these? But I already knew it was a kidney graph. So I'm going to go ahead and just kind of connect and kind of make that kind of arced shape there around a shape. And then I'm going to do that kind of matching little divot here because that gives me that kidney. And then I'm going to swoop around to connect in and then swoop around to connect in. Okay? All right, so let's take a look at question number 5. So we're going to try to graph this one without doing a table. Oop, 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 oop. I always forget my start and stop. Okay, so our start and direction. So at 0, 6, I'm going to go to 0, 6, which is this guy right here, and then head towards my pi over 2, or in that positive direction of counterclockwise. Okay. All right, now on to number 5. Okay, so I'm going to go ahead and get a graph going here. So I always want to have at least theta equals 0, right? So, because that gives me my start. So I'm going to have 6 minus 4, and then the sign of 0. And I know that sign of 0 is 0, so 6 minus 0 would be 6. So all right, and then, so let's go ahead and work this one out. So if I look at this, I know that I have a negative sign, right? So where is sign negative? So sign is negative down here, right? So I know the bulk of my graph is going to be down in this way. And then I know that 6, which is my A value, is bigger than 4, which is my B value. So bigger than, greater than, not less, not less, not less, no loop. Okay, la 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 la. So then this is not going to have a loop, so then it's going to be my kidney graph, right? So this is going to be my kidney. So that means in general my graph is going to do, you know, something like that. So then my shoulders are here, which are the A value. So my shoulders are at 6. So I already have that first one that I got just from evaluating at 0. So I'm just going to mirror that over on this side as well. And then I add 6 and 4 together, so that gives me 10. So that's going to give me this value down here. So 6 plus 4 is 10. And then subtract them, which is going to give me where my little divot spot is. So 6 minus 4 is 2. And that's where my divot will be. So then I'm going to connect these to give me that kind of bulk of the graph. And then I'm going to make kind of little miniature version of it up here for that divot, and then up and around to get to the ends. Okay, and so there that one is. And again, like if I wasn't sure, right, if I didn't know, then I would go through and I would do a t-table, right, finish filling it out and get all of those values. All right, so but my start was here at 0, 6, and then we're always headed towards pi over 2 in that positive counterclockwise direction. Okay. All right, and let's do another one of these guys. So for this one here, so I have 3 minus cosine theta. So again, I look here, so my A value is 3, and I know it is greater than 1, right? So we're looking at the absolute value form. Don't look at like, oh, but it's subtracting, it should be -1. Just look at it as the 3 and the 1. So because it is bigger, so 3 is bigger than 1, greater than, it's going to be a kidney graph. If it was less, it's a limosone with a loop, L's, all those L's together, okay? And then I have a negative and I have a cosine. So negative cosine, so cosine's negative to the left. So that graph, the bulk of that graph is going to be left, and then I'm going to get the little divot on the other side there. Okay. So again, you always want to make sure you're evaluating at least at 0 so you know where that start point is. So this will be 3 minus cosine of 0, and I know cosine of 0 is 1, so 3 minus 1, so that would be at 2. So at 0, I'm going to go 2 units towards it, so that would be right there. So I just found the divot, right? That's what I found right here. So now let's go ahead and take a look at graphing here. So I know my shoulders, so these guys right here are going to be on the vertical line. My shoulders are on the vertical line, and that would be at my A value. So my shoulders are always at that constant, that A value. So 1, 2, 3. 1, 2, 3. Okay, so there's my shoulders always at that constant, the A value. And I know it's on that vertical line because I know the orientation based upon sine, cosine, positive, negative. Okay, so then I would subtract them. 3 minus 1 is 2 for the divot, and I already found that. And then I want to add them to get how far this way am I going to go. So 3 plus 1, which would put me at 4. Okay, and I'm going to go ahead and connect those and get kind of that rounded shape. Not very well, but there it is. And then kind of mirror that over on this side right here, get the little divot, and then swoop back and around just to kind of make it look like a little kidney or a little kind of a pushed in heart shape, I guess. Okay? All right. So let's do another page. So last one here. Or last page, not last problem, but last page. Okay, so theta equals pi over 4. So this is just a line, right? Because we're just going to, where is theta equaling pi over 4? This pen doesn't want to say. So I go to first, where is theta pi over 4? So that's in quadrant 1, so pi over 4. I'm going to start at the pole, and then just draw in that radial line of pi over 4. And so that would be the graph. So those are pretty easy, right? You just need to figure out, well, where the heck is pi over 4? Rotate to that value, and then from the pole, mark that radial line, okay? And you don't need to go the behind one, because that's not pi over 4, right? Okay. All right, and then let's do another one. And again, make sure you're pressing pause, right? You're trying these, and then you're looking, flash forwarding, seeing, did I graph it right? And then move on to the next one, okay? All right, so theta equals negative 2 pi over 3. So negative meaning we're going to go that way, right? So this would be 3 pi over 3, but negative. And this would be half of that, so that would be negative 1.5 pi over 3. So it's somewhere over in this quadrant right here, closer to the 1.5 than the 3. So that would be somewhere right around there. And again, we start at our pole and head towards that angle, so that would be this guy right there. And that's it. Like, that's all you have to do on that one, is you're just graphing that little section of the radial line from the pole. Okay, so let's take a look at 9 and 10. So our secant cosecant graphs, like these are the linear graphs, and so a couple of ways to do this is do your conversion, or if you happen to like already have kind of your cosecant secant graphs memorized, you know, oh, is it y, is it x, that sort of thing. So the way you should be kind of thinking a couple of things is, you know, cosecant is your sine reciprocal, right? So sine is your y value, so y over r. So sometimes that's like a good way to kind of like trigger your mind into like, oh, it's sine, and so it's y, so this is a y equals graph. Or you can, you know, just do your substitutions. And so the reciprocal of sine is cosecant, so the reciprocal ratio would be r over y. So I'm going to take that guy right there and substitute that in. And then always clear your fractions when you're doing kind of a, whatever this is called. I'm trying to blank. What am I doing? I'm turning it into something, but I know there's a mathematical word, but I've totally forgotten. But anyway, I'm doing that thing. Okay, so the y's are going to cancel. So I would have ry is equal to negative 3r, and then get rid of those r's by dividing by both sides. So I would have y equals negative 3. So I'm going to go to the y-axis at this is a stubborn pen, it keeps rolling. So I'm going to go on the y-axis, which is this one right here, and I'm going to go down to 3, so right there, put a dot, and then I cut through the y-axis at -3. And again, like if you forget secant and cosecant, like if you do remember, oh, cosecant is the sine, which is my y value, we know we're going to end up with that y equals. Okay. All right, last problem, number 10. So for this one here, so again, if I happen to know secant is cosine, cosine is my x, I know it's an x equals graph, right? Okay, so I can shortcut a little bit there. So I'm going to start with, I know that cosine is x over r, and the reciprocal of cosine is secant, and its reciprocal ratio is r over x. So I'm going to take that and swap it out for that secant. Then I'm going to multiply both sides by x. And then divide both sides by r. So then what I'm graphing is x is equal to 5. So I'm going to go along the x-axis to 5. And then cut a line through x equals 5, and there's my graph. And then that's it. So if you have any other questions, make sure you reach out to your teacher. Okay? All right, bye.